In this video, you're going to learn how to make a coordinate graph of your data. First thing we're going to do is use as much space as we have. That's a whole sheet of graph paper. We're going to use it all. Next thing, we'll be drawing our x and y axes. We're going to actually do those on the edge of our grids, of our squares. And we're just going to put the ruler there, draw a nice dark line, put arrows on both sides of it, do the same thing with the other axes. Put the arrowheads on there. Go ahead and label those X for the horizontal and Y for the vertical. Next, we're going to label the axes with our actual variables. Scientists have agreed that the horizontal, or the x-axis, is going to be used for the independent variable in the experiment. Even though they don't write independent variable, we're going to do it just to help us remember and learn. After independent variable, even though you can't see it because I didn't actually move the page in front of the camera, you need to write volume, which is the independent variable, and after that, parentheses, ml/cm cubed. Those are the units of our volume. Volume is the independent variable because it's the one that we're going to look at and see how it changes to see if it affects the dependent variable, which is the mass. On the y-axis, that's the vertical one, scientists write the dependent variable. Now, again, they don't write dependent variable on there. We're going to do it just to help us learn. And our dependent variable is the mass, parentheses, grams, which is the units. Next thing we're going to do is determine the scale for our axes. In other words, the numbers we're going to write on the marks on the side. To do that, you need to know the upper limit of your data. For us, the mass won't go above 500 and the volume won't go about 500 milliliters either. You need to count the number of squares you have from the bottom to the top of the axis. 1, 2, 3, 4, 5, 50. Perfect, because I have 500 grams. 50 squares means I can do 10 grams per square. Now I'm going to make marks every 5 squares. I'm going to go back later and actually write the numbers on there, but for the moment just mark off every 5 all the way to the top. I'm going to label those 50, 100, 150, 200, 250, 300, 350, 400, 450, and 500. Do the same thing along the x-axis. Every 5 squares make a mark, every 5 squares make a mark. Keep doing that all the way, and then go back and label them 50, 100, 150, 200. Notice you can see it says independent variable, volume, milliliters, centimeters cubed. And then put a 0 right there in the corner. Last but not least, putting the title on the graph. For 6th grade, our title is going to be simple. We're just going to name the 2 variables that are in our graph. The independent variable first, we're going to say volume, and mass, which is the dependent variable. We're also going to add a little detail in various objects. Simple, that's all we need. We're almost done. Now we're going to make the key. For the key, this is where you actually say what symbols you're going to use to represent which objects. So for starters, I'm just going to say equals wooden blocks, equals rubber stoppers. I'll fill in the symbols at the very end. Equals clay, equals water, and equals brass masses. We'll use a dot for the wooden blocks, we'll use an X for the rubber stoppers, etc. You can choose whatever symbol you want. Now let's plot some points. This is for our data from the tables and volumes and mass. So the first thing I'm going to do is I'm going to look at my volume column, because that's going to be what I put on my x-axis where it says independent variable volume. Notice I went to 16 about, because that's what my first object is, a small wooden block. So I go over 16 to the right. It's got a mass of 7 grams, so I'm going to go up not even 1 square and put a dot right there. That dot represents 16 cubic centimeters and 7 grams. I put a dot because that's the symbol for my wooden block. Next wooden block has a volume of 32 cubic centimeters. So I go about 33 squares over, and then I go 1.5 squares up because it has a mass of 15 grams. Put a dot there because that's the symbol for wooden block. And the final object is a large wooden block, is going to have a volume of 64 cubic centimeters, so I go over past the 50, past the 60. It's going to be 30 grams, so I only go up 3 squares, and I put the dot right there on the line that represents 30 grams. So there's my dot for 64 cubic centimeters and 3 grams. For my next objects, I'm going to use water, and I'm going to start with 100 milliliters of water, which has a mass of 100 grams. So I put the triangle right there. Now I look on the x-axis for 250 milliliters because that's my next volume of water. It has a mass of 250 grams. That's why I'm going up to the 250 gram mark. And finally, 500 milliliters of water over on the x, all the way up to 500 grams of mass on the y-axis, and put my triangle mark there. That's as far as we'll get with making this graph. If you have time, measure more objects and add them to your graph. You should have a nice graph now. Go ahead and take a picture of that and insert it into your science website.